The number system. Hello everyone. Welcome back to Infinity Math. In this lesson, we'll begin one of the most important topics in mathematics, the number system. Every number you've ever used belongs to a certain group. Today we'll learn about natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers, operational properties, learning objectives. By the end of this lesson, you will be able to define each type of number, identify which set a number belongs to, compare different number sets, solve classification questions. Let's get started. What is a number system? A number system is a way of organizing numbers into different groups based on their properties. Think of it as a family tree. Each group contains certain numbers, and some groups are larger than others. Natural numbers. Natural numbers are the counting numbers. These are the numbers we use for counting objects. Symbol. N equals 1, 2, 3, 4, 5. Which of the following are natural numbers? 5, 0, minus 3, 12. Answer. 5 and 12 are natural numbers. Whole numbers. Whole numbers include every natural number plus 0. Symbol. W equals 0, 1, 2, 3, 4. Difference between natural and whole numbers. Natural numbers start at 1. Whole numbers start at 0. Integers. Integers include positive numbers, negative numbers, 0. Symbol. Z equals minus 3, minus 2, minus 1, 0, 1, 2, 3. Negative numbers are useful for temperature, bank balances, elevators. Example. If the temperature is 5 degrees Celsius below 0, we write minus 5 degrees Celsius. Practice. Which are integers? Minus 12, 3, 0. For over 5. Answer. Minus 12, 3 and 0. Rational numbers. A rational number is any number that can be written as A over B, where A and B are integers and B is not equal to 0. Examples. 1 over 2, 3 over 4, minus 5 over 8. 7 is equal to 7 over 1. 0 is equal to 0 over 1. Decimal examples. 0.5, 0.25, 0.333. All terminating and repeating decimals are rational numbers. Irrational numbers. Irrational numbers cannot be written as a fraction of two integers. Their decimal expansions never end and never repeat. Examples. Square root 2, square root 3, square root 5, pi. pi equals 3.1415926.535. The digits continue forever without a repeating pattern. Real numbers. Real numbers include every number on the number line. This means they include natural numbers, whole numbers, integers, rational numbers, irrational numbers. Examples: -10, 0, 5/6, square root 7, pi. All of these are real numbers. When we look at the table, the list of the grouped numbers on column, and the operational properties on the row. If you observe the irrational numbers, they are not closure under all operations. All the grouped numbers except irrational numbers have closure property under addition. Only integers, rational numbers, and real numbers have closure property under subtraction. Except irrational numbers, multiplication is closed overall. Division is not closed overall. All numbers are commutative under addition and multiplication. All numbers are associative under addition and multiplication. All numbers have a distributive property. 0 is an additive identity over all numbers except natural numbers. 1 is a multiplicative identity over all numbers. Only integers, rational numbers, and real numbers have an additive inverse. Only rational and real numbers have multiplicative inverse. Relationship. Notice something interesting. Natural numbers are inside whole numbers. Whole numbers are inside integers. Integers are inside rational numbers and rationals are inside real numbers. Practice questions. 1. Is square root 9 rational or irrational? 2. Is 0.75 rational? 3. Is pi rational? 4. Which set contains every number on the number line? 5. Is -15 an integer? Pause the video and try them yourself. Write on the comment section if you have any question. Congratulations! You have now learned the complete number system in a short period of time. Natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers. These concepts are the foundation for algebra, geometry, calculus, and many other branches of mathematics. If you found this lesson helpful, please like the video, subscribe to Infinity Math, and share it with someone who wants to build a strong foundation in mathematics. See you in the next lesson.